Hi, and welcome to the Valid Manufacturing EECOHEAT presentation. Over the next few minutes, we'll show you how the EECOHEAT heat reclamation system turns ordinarily wasted energy into usable, cost-saving recovered energy. It is widely accepted that a finely tuned, high-performance internal combustion engine can at best achieve a mechanical throughput efficiency of about 30%. This means that for every bit of energy consumed by an engine, less than a third of it will be converted into usable mechanical power. Some of the remaining energy is of course used up in the sheer effort required to run the engine and overcome the friction between the engine's various parts, but the vast majority of the remaining energy escapes right out the exhaust in the form of heat. Unfortunately, we typically use the engine to create rotating mechanical power. If we could somehow harness the heat as well, then the available power from the engine is much greater than what is normally achieved. The Valid Manufacturing Engine Exhaust to Crude Oil Heat Exchange and Transfer System, or EECOHEAT, simply takes that waste heat and turns it into value. Valid's EECOHEAT system has been designed to integrate seamlessly with your already proven industrial engine power plant. At the heart of this new product is the same engine that you have come to trust for its cost-effective longevity. Although the power plant remains unchanged, the Valid EECOHEAT product adds some new components and features to the exterior of the engine. This allows you to effectively harness heat energy which normally would have escaped into the atmosphere. The first addition is a high-flow, high-efficiency stainless steel exhaust manifold system that enables the exhaust gases to flow out from the engine in an unrestricted manner. The manifold guides combustion heat out and away from the engine. The heavy-duty stainless steel exhaust tubing used for the manifolds and throughout the entire exhaust system is more than capable of handling the extreme temperatures that are produced by the engine. The next addition is of major importance in making sure that there is never an interruption to the power-producing capabilities of the engine. Flow from the exhaust manifolds is combined and directed to a bypass diverter system that, if necessary, will allow the engine exhaust to be vented out to atmosphere just as it does on the standard engine. During normal operation, the bypass remains closed, directing engine exhaust into the EECOHEAT system. It will, however, automatically open to vent any excess heat being generated by the recovery system that is not required by the oil heating system. The bypass line also opens if anomalies are found in any of the temperature or flow sensors incorporated in the system. The Valid EECOHEAT system automatically regulates the amount of heat reclaimed in order to adequately meet the requirements of the oil heating process. The main component of the Valid EECOHEAT product is a high-efficiency stainless steel heat exchanger. This device takes exhaust gases in at temperatures in excess of 700 degrees Celsius and transfers that heat to a counterflowing high-efficiency thermal transfer fluid circuit that runs throughout the system. It is not uncommon to see a 600 degrees Celsius drop in temperature as the exhaust gases pass through the high-efficiency exchanger. The extremely efficient and robust design of this component is the key element of the EECOHEAT product. The flow through the heat exchanger has been optimized through computer analysis to provide the highest possible amount of heat transfer while maintaining an unrestricted flow of exhaust gas. The thermal transfer fluid used in the Valid EECOHEAT product has extremely efficient thermal transfer characteristics and is completely non-toxic and biodegradable. Not only does it do an excellent job of ensuring that all available heat is transferred to the bitumen tank, but it also provides for a safe and environmentally friendly process. In addition to heat reclaimed from the engine exhaust gases, heat from the engine's cooling jacket fluid is also scavenged in order to recover the maximum amount of heat possible. The engine glycol is circulated through a high-efficiency double-walled brazed plate heat exchanger, thereby transferring the engine heat into the high-efficiency thermal transfer fluid. Just as in the exhaust bypass system, the flow of engine coolant heat can either be directed through the brazed plate heat exchanger or allowed to simply circulate through the radiator in its standard fashion. The onboard control system determines when to include the engine coolant flow and when not to. As in other parts of the system, if any anomalies are found in the system's temperature or flow sensors, the engine coolant is immediately directed to flow through the radiator so that proper engine cooling is always maintained. In order to contain and manage the extreme heat of the engine exhaust gases, metal enclosures filled with high-temperature rated ceramic insulation are used to encapsulate the entire exhaust path leading right from the engine to the heat exchanger. In addition to making the system more thermally efficient, these enclosures also increase personnel safety and reduce heat-related injuries. The exhaust gas outlet from the heat exchanger, as well as the outlet from the exhaust bypass line, are then both directed into an Atom Integrated Industries custom-engineered Class 6 stainless steel engine silencer. This silencer has been acoustically engineered to significantly reduce both high and low frequency sounds while still providing extremely low back pressure on the engine exhaust. The entire engine and heat reclamation system are then housed in a state-of-the-art Atom Integrated Industries sound attenuating enclosure. By insulating the entire exhaust tubing assembly and then placing the engine and its silencer within the overall sound-canceling enclosure, we are able to provide one of the quietest engine power plant installations available while reclaiming much of the valuable heat that would normally be wasted in the power generation process. Once the heat has been transferred into the thermal transfer fluid circuit, we need to transfer it again, this time into the bitumen tank. This is done by passing the heated fluid through a series of coils placed inside the storage tank. In order to support the heat coils, a fabricated steel structure is placed inside the tank. This structure, along with the heating coils, can be either provided as a complete assembly or in kit form designed for retrofit installation. The heating coils are installed in multiple concentric helical assemblies. The thermal fluid is pumped into the bottom of these assemblies and travels upwards through the spiraling coils, exiting at the top. This ensures that no air is trapped within the heating element coils. Tube extensions are attached to the inlet and outlet of the heating coil so that the thermal transfer fluid circulation connections can be made on the side of the storage tank. The completed tank exchanger is fully contained within the storage tank. If desired, a standard burner tube can still be installed in order to provide supplemental heating during periods of extremely low ambient temperatures. Testing has shown that the amount of heat that is made available to the tank heating system is directly proportional to the amount of work being done by the engine. Every well is different, so the energy available from each one is also different. The following graphs indicate how much heat reclamation can be expected for a given well site based on the amount of mechanical or hydraulic work being done by the engine power plant. The values shown are all based on the power plant engine being a propane-fired 5.7-liter GM industrial engine. By implementing the valid EcoHeat product, oil producers can expect to see reductions in their propane consumption at each well site by as much as 50%. In addition to the obvious and significant cost savings, it is anticipated that these same producers will also benefit from a net reduction in CO2 emissions of between 100 and 200 tons per well site per year. With its optional data recording and analysis package, the valid EcoHeat product can provide historical and real-time data from the wellhead drive. All aspects of the system can be monitored, such as system temperatures and heat recovery levels. It can even determine the actual reduction of CO2 emissions at each well site by determining how much propane was not used to run the burner. Customers can choose to have full access to the data or just monthly summaries. If necessary, the EcoHeat system can even send out text messages to inform your personnel of any service requirements that are necessary. As you can see from the preceding slides, the valid EcoHeat system recovers ordinarily wasted energy and reclaims a great deal of ordinarily wasted value. The EcoHeat system is proven to increase the efficiency of your business, all while dramatically helping your bottom line. For more information, contact Valid Manufacturing today or visit www.validmanufacturing.com to put EcoHeat to work for you.